GenAI and MLOps Part 22. This episode has 7 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain TensorFlow serving. Here's a strong way to approach it. TensorFlow serving is a high-performance model serving system developed by Google for deploying machine learning models in production environments. It is mainly used to serve TensorFlow models for real-time inference through REST or gRPC APIs. TensorFlow serving allows models to be loaded dynamically, version scaled, efficiently updated without downtime. Key features include high-performance inference, model version management, REST and gRPC endpoints, hot model reloading, batch request support, Kubernetes and Docker integration in production MLOps systems. TensorFlow serving is commonly used for real-time prediction APIs, large-scale inference workloads, GPU-accelerated serving, canary or blue-green model deployments. Example workflow. 1. Train a TensorFlow model. 2. Export the model in saved model format. 3. Load it into TensorFlow serving. 4. Expose prediction APIs for applications. TensorFlow serving is widely used because it provides low latency, scalable, and production-ready ML model serving capabilities. Nice. Let's continue. Question 2. What is TorchServe? Here's a strong way to approach it. TorchServe is an open-source model serving framework developed for deploying and serving PyTorch machine learning models in production environments. It is designed to provide scalable and high-performance inference for PyTorch models through REST and gRPC APIs. TorchServe helps with real-time inference, batch inference, model version management, auto-scaling, monitoring, and logging. Key features include multi-model serving, GPU support, custom handlers for pre-processing and post-processing, REST and gRPC endpoints, metrics integration with Prometheus, Kubernetes and Docker support. Example workflow. 1. Train a PyTorch model. 2. Package the model into a .mar archive. 3. Deploy it using TorchServe. 4. Expose APIs for prediction requests in MLOps. TorchServe is commonly used for scalable deployment of deep learning models in production systems, especially for NLP, computer vision, and generative AI workloads. Great. Moving on. Question 3. What is BentoML? Here's a strong way to approach it. BentoML is an open-source MLOps framework used to package, deploy, and serve machine learning models in production environments. It helps convert trained ML models into scalable API services that can be deployed on cloud platforms, Kubernetes, or Docker containers. BentoML supports multiple ML frameworks such as TensorFlow, PyTorch, Scikit-learn, XGBoost, Hugging Face models. Key features include model packaging and versioning, REST and gRPC API serving, Docker and Kubernetes integration, auto-scaling support, batch and real-time inference monitoring and observability integration in MLOps. BentoML is commonly used to simplify model deployment and standardize inference services across teams. Example workflow. 1. Train a model. 2. Package it as a Bento service. 3. Containerize using Docker. 4. Deploy to Kubernetes or cloud platforms. 5. Expose prediction APIs. BentoML is popular because it provides an easy and production-ready way to operationalize ML models with scalable serving infrastructure. Alright, next question. Question 4. Explain Selden Core. Here's a strong way to approach it. Selden Core is an open-source MLOps platform used to deploy, scale, manage, and monitor machine learning models on Kubernetes. It allows teams to serve ML models as production-grade microservices with support for advanced deployment strategies and observability. Selden Core supports models built using TensorFlow, PyTorch, Scikit-learn, XGBoost, ONNX custom Python models. Key features include real-time and batch inference, Kubernetes native deployment, auto-scaling A or B testing, canary deployments, model monitoring, explainability integration, REST and gRPC APIs in production MLOps systems. Selden Core is commonly used for large-scale model serving, multi-model deployment, traffic splitting between model versions, production monitoring and governance. Example. A new ML model can be deployed alongside the existing version, with only 10% of traffic routed to the new model for canary testing. Since it is Kubernetes native, Selden Core integrates well with Kubernetes, IceGeo, Prometheus, Grafana. It is widely used for scalable and production-ready ML model deployment in cloud-native environments. Let's keep going. Question 5. What is Kserve? Here's a strong way to approach it. Kserve is a Kubernetes native model serving platform used to deploy, manage, and scale machine learning models in production environments. It is built on top of Kubernetes and native and provides serverless inference capabilities for ML workloads. Kserve supports multiple ML frameworks such as TensorFlow, PyTorch, Scikit-learn, XGBoost, ONNX. Hugging Face models. Key features include real-time model serving, serverless auto-scaling, GPU support, Canary deployments, A or B testing, model versioning, REST and gRPC APIs, inference graph pipelines in MLOps. Kserve is commonly used for scalable inference services, Kubernetes-based ML deployments, dynamic auto-scaling based on traffic, multi-model serving, production-grade model management. Example: a deployed model can automatically scale down to 0 when there is no traffic and scale up instantly when prediction requests arrive. Kserve integrates well with Kubeflow, Istio, Prometheus, Grafana. It is widely used for cloud-native, scalable, and production-ready ML model serving. On to the next one. Question 6. Explain model governance. Here's a strong way to approach it. Model governance is the process of managing, controlling, and monitoring machine learning models throughout their life cycle to ensure they are reliable, secure, compliant, and auditable. It helps organizations maintain transparency and control over how models are developed, deployed, and used in production. Model governance typically includes model versioning, approval workflows, access control and security audit trails, compliance tracking, monitoring and drift management, documentation and reproducibility in production MLOps systems. Governance is important because ML models can directly impact business decisions, customer experience, and regulatory compliance. Example: before promoting a model to production, organizations may require accuracy validation, bias and fairness checks, security reviews. Business approval governance also helps with rollback management, risk reduction, accountability, regulatory compliance. Common tools used for governance include MLflow, Kubeflow, weights and biases, cloud model registries and monitoring platforms. Overall, model governance ensures ML systems remain trustworthy, controlled, and production-ready at scale. Good. Here's another one. Question 7. What is explainable AI? Here's a strong way to approach it. Explainable AI, XAI, is the practice of making machine learning model predictions understandable and interpretable for humans. It helps explain how and why a model made a particular prediction or decision. Explainable AI is important because many advanced ML models, especially deep learning models, behave like black boxes where the internal decision-making process is difficult to understand. XAI helps improve transparency, trust in ML systems, debugging and troubleshooting, regulatory compliance, bias and fairness detection. Example: in a loan approval system, explainable AI can show which features, such as income, credit score, or loan history, influenced the prediction. Common explainability techniques include feature importance, SHAP values, Lime partial dependence plots, attention visualization. In MLOps, explainability is important for monitoring, governance, auditing, and ensuring responsible AI practices in production systems. Common tools include SHAP, Lime, Fiddler, AIY Labs. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.